To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. I like food. I also like people. And you know what? You can combine those things together. No, not like that. No, I mean like with a small potluck for only lasagna. You know? For people who, like me, have a very healthy relationship with lasagna. But regardless of the shindig, it's going to have a guest list, and somehow you are going to need to keep track of it. Sure, you need the names of who's invited and whether they RSVP'd, but you might also need their phone number, email address, meal choice, whether or not they're lactose intolerant, favorite song, whether they're bringing a +1, their thoughts on lasagna, so you know whether or not to disinvite them. The list goes on. Party planning isn't easy. But computers are powerful information processing tools. They can sort through details way faster than my little brain can. Still, you might doubt that Java can really handle all of this information at once. Like, we could try to cram all of this stuff into an array list, but those only store one data type at a time. However, with a tool called classes, we can create a program to organize our guest information efficiently and avoid any potential mishaps, like allergic reactions or a boring playlist. Hi there, I'm Sabrina Cruz, and this is Study Hall, code and programming for beginners. So you might be thinking, there is a way to store all this data with ArrayLists, Sabrina, and technically, yeah, you can use parallel arrays to store each data type separately while showing that they're related with indexes. Look at you, you're paying attention and learning programming. But here's why that's a bad idea. To keep this example pretty simple, let's say we just want to keep track of 4 things about our party guests: their names, ages, favorite drinks, and whether or not they're lactose intolerant. We would need string arrays for the names and drinks, an integer array for ages, so we know who to put at the kids' table and who to put at the old folks' table, and a Boolean array for lactose intolerance. But let's be realistic here. With parallel arrays, we'd have to somehow remember that our friend Zach is represented by index number 6. That could work. I am very good at remembering numbers, but a single shift in one array could mess up all the data. And just think, if just one lactose intolerance variable in the Boolean array gets mismatched for the correct guest, there could be some dangerous consequences. Another thing to consider is scalability, which is the ability for the same code to be used at a larger scale with more inputs. If we needed to keep track of more data about each guest, from their contact info to RSVPs across a bunch of events, we might need tens or hundreds of parallel arrays. That would get pretty difficult pretty fast. Or what if, instead of a small lasagna potluck, we were planning a huge music festival and we had to keep track of 50,000 guests? With so many indices to worry about, the whole system of parallel arrays would just fall apart. Maybe that's why Fire Festival was a disaster, along with the terrible wages and treatment of local people. Anyway, really we need something that can hold multiple data types, something that scales, and ideally something that helps us keep track of individual guests without needing to assign them a number. Behold, the class! A class is basically a template that lets us define objects that associate different pieces of data and methods that operate them in one place. So going back to that purely hypothetical lasagna potluck, we can build a generic party guest class that includes all the types of information we need for each person on our guest list. And because we're defining the components of our class here, this part of the setup is called the class definition. To define our class, we need to differentiate between categories that belong to all members of the class party guest and specific variables that belong to each individual guest. For example, every party guest will have a name, and only one of those names will refer to our friend Zach. So the idea of storing a name is a category that belongs to everyone who's a party guest, but a specific name is a variable that belongs to an individual guest. Once we've defined our party guest class and have our class definition ready to go, we want to actually customize instances of it for each person. To do this, we create a public method called partyGuest that takes an argument for each of the 4 categories in the template. Remember, we're tracking names, ages, favorite drinks, and whether or not they're lactose intolerant. Because this block will be used to construct our individual guests, we call it a class constructor. A class constructor has a lot of this floating around in its code. And I mean that literally, the word this. Within Java classes, this is how we differentiate between the class template and the representation information of an individual guest. Also, you don't actually need to write out the entire constructor for your class to work. If you don't explicitly specify one, Java will automatically give you a constructor that takes no parameters. Java will assign default values to the categories in your template. For our party guest class, the defaults might be an empty string for name and favorite drink, 0 for age, and true for lactose intolerance. Better safe than sorry. This system is named the default constructor. Now that we have our class constructor, we can use the party guest template to create what's called an instance or object of the party guest class. For each object we create, we need to fill in the specific qualities that apply to one of our guests. In this case, our friend Zach. Technically speaking, an object uses a specific class as a blueprint, and when we create an object, we're instantiating that object. What a great word. Instantiate. Meanwhile, the arguments we supply to the object constructor are generally stored in the object's instance variables, or attributes. These are the specific qualities that can be accessed anytime by using the dot operator. For example, age is an attribute and 25 is its value. That's the integer argument we supplied for Zach's age. This age data is part of the guest object, and it's really easy to pull it at any time we want. We just need to tell our computer to print guest.age, and the output will be 25. Whew, that is a lot of new Java jargon all at once. So to make sure everything's clear, let's use these new terms together. Favorite drink is an attribute of the party guest class, and ginger ale is a value that can be stored in that attribute for a particular guest. In plain English, we would say that every guest has a favorite drink, and our guest Zach's favorite drink is ginger ale. Two party guest objects will store different information, but they store that information the same way because of how the entire class is defined and because both objects are instantiated from the same class. So, when I said Zach's lactose intolerant attribute to false, that only applies to his instance. I need to set every other instantiated object's lactose intolerant attribute separately, even if it's also false. Like if we had another guest2 object for our other friend, Cody. But if I add a new attribute in the class definition section, like phone number, then every instance of the class now has that attribute. There would be a place to store a phone number in Zach's instance, Cody's instance, and every other party guest instance that I have, in case we want to use it. And I would need to supply this new data to each one separately. That's the beauty of class instances. They're both uniform and individualized. Classes strike a balance between establishing consistency and allowing for exceptions to the rules. Anyway, that's why classes are really powerful tools in Java for both data storage and functionality. We can use classes to create basically any instances we can dream up, as long as they serve the same purpose. Like, you can build a class that lets you specify the paint color, sofa size, and number of chairs in a living room. This allows you to use the same template to create instances with different themes. They all have common attributes, and they all have unique details. You can build a class that represents a D&D character, a user on a social media app, a music playlist, or even a monster fight? That's a spoiler for an upcoming episode. Now, I'm gonna let you in on a little secret. We've been using classes this whole time. We just held off on talking about them because, well, there's a lot going on in computer science, and we didn't want to throw you in the deep end without some basic swimming lessons first, you know? We're used to seeing this syntax in Java. Data type and variable name equals new data type. Back when we initialized our first array list, we used this format. But what we're actually doing here is creating a new instance of the array class. Sneaky, right? The same goes for all of the strings we've been using. They're instances of the string class. Now, strings are easy to initialize because Java is programmed to instantiate them in most cases, but the same class construction is still happening under the hood. Unless, of course, you're trying to create the same string twice. We dove deeper into those subtle differences in episode 20 if you want a quick refresher. The point is, any non-primitive data type in Java needs to be constructed. We already talked about how attributes belong to a specific class, like how the attribute age belongs to the class party guest, and we can access the data stored in an attribute using a specific object variable, instance variable, and a dot operator, like guest.age. Similarly, methods accessed with a dot operator also belong to a specific class. For example, I can only use the add method with an ArrayList object. If I try to use the add method on a string, that would throw an error because there's no add method defined inside of the string class. That's just not how strings work. We write methods into a class definition alongside any attributes. You can tell the difference between them at a glance because methods have parentheses to hold parameters and attributes won't have any. As a human, you may naturally view the world as a collection of things that each have their own characteristics and behaviors, and classes let us capture this abstract perspective in our computer programs. Especially in languages like Java, where everything is an object, we need to understand classes to translate our ideas into code. So, as a programmer, it's always good to understand which aspects of classes and methods can be handled for you, and which ones you always need to write yourself. No matter what project you're working on, whether it's planning a party or building a complex software system, embracing the power of classes will elevate you to a new class of programmer with code that is more organized, scalable, and maintainable. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, check out gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.